Welcome back, geographers. So this is EQ4 of Coastal Landscapes and Change, your revision guide to all of the topics in the A level. And EQ4 looks at how coastlines can be managed and how we meet the needs of all of the stakeholders and players involved. So remember that you've got a coastal revision booklet that you can fill in as we go through this. And also remember that this is not a replacement for your lesson learning. It's just a way in which you can revise the topic in a short way and look through the main learning content bits that you did in lesson. If you did not see EQ1, 2, or 3, please go back now and watch those before you watch this GeogPod. So let's get started. The first thing to note about EQ4 is it mainly looks at the impact of coastal problems. So a big theme throughout these is the social and economic losses due to coastal recession. So the coastline receding inland due to erosion and the general social and economic losses as a result. Now, these are very general to start with, and then we'll apply them to case studies next. So social losses include the relocation of people, the breakup of communities, the loss of livelihoods, incomes and financial problems, the loss of people's livelihoods and things that can't be quantified in value terms, and the loss of amenity value like culture, human well-being, and so on. The economic losses include the costs involved economically, for example, with relocating housing and roads. Things like business loss, depopulation, falling property values, loss of assets and land, uncertainty in terms of insurability of homes, and the Environment Agency, for example, estimating 800 properties will be lost in the UK by 2035 due to coastal recession. These are all economic losses. So let's now apply that to two case studies. Here we've got the Holderness Coast in the UK, a developed nation, and Bangladesh, which is a developing nation. I'm going to put up all of the Holderness Coast to start with on screen, and I'm going to give you a minute or so just to read through what is there. Okay, so that was about 30 seconds. So you should have been able to just glance over that list. So let me just talk through some of the main points here. So the social impacts of coastal recession in the Holderness were things like property prices falling sharply, 30 villages lost since Roman times. There's been lost farmland, there's been lost homes. It's very difficult to get insurance if you live along this coastline, and people cannot afford the repairs to the homes that they need. In terms of economic impacts, there has been a drop in tourist numbers by around 30% since 1998. Outward migration has been happening, particularly of young people. Infrastructure loss. Settlements have had hard engineering schemes put in place to prevent flooding, like sea walls, which are very costly. And existing coastal defences have been damaged. For example, the groins at Mappleton were severely damaged by storm surges, and this needs to be replaced, and that costs even more money. Now, in terms of a developing nation, we're going to look at Bangladesh. So I'm going to again give you 30 seconds or so with the social and economic impacts of storm surges and coastal flooding there. Okay, so you can see with Bangladesh that we've got a lot of data on this because it was in 2004. It was a very, very damaging event. So we have got quite a bit of data we can use in our 12 and 20 mark answers here to back up the points we make in our explain section for evidence. So at least 10.5 million have been displaced or moved from the coastline of Bangladesh since the 2004 floods. Diarrhea, drowning, landslides, and diseases have killed 100,000 people. And there has been large scale loss of homes with severe consequences for poverty and disease as well. In terms of economic impacts, there have been one of the key cohorts that have lost out due to flooding in Bangladesh is farmers. Now, farmers have suffered heavy income losses due to crop failure and crop being destroyed. So in 2004, they had this problem twice in 1 year. Severe economic impacts on farmers there. 150 million US dollars in aid was needed. 290 million US dollars worth of crops were damaged in the initial 2004 floods. There's been damage to schools and hospitals alone, estimated at 7 billion US dollars. So severe impacts of the Bangladeshi floods and storm surges there compared to the UK ones. Now, a case study you did in this topic in relation to environmental refugees due to flooding and sea level rise and so on is Tuvalu. So remember, environmental refugees are those who are forced to leave their homes due to natural processes like landslides, flooding, rising sea levels, erosion, etc. So the Intergovernmental Panel on Climate Change predicts that sea level rises of 26 to 82 centimeters will happen by 2100. And that will have severe impacts on places like Tuvalu due to flooding and saltwater encroachment, which means that the farming industry will be destroyed, agriculture, particularly in terms of crops, drinking water, irrigation, and industry would also be damaged as a result. Now, remember, Tuvalu's highest point is around 5 meters above sea level, but most of it is only 1 to 2 meters above sea level. So what's happening is New Zealand has granted residency to 75 Tuvalu citizens each year under what's called the PACB, the Pacific Access Category Ballot, as rising sea levels decrease its land area. In 2014, New Zealand's courts granted the Alasana family permanent residence on their land bases due to climate change refugee status. So increasingly, island nations close by, like New Zealand, are helping the citizens of Tuvalu each year move out of the coastal areas of Tuvalu to New Zealand to safety, and these people are environmental refugees. Now, let's move on to coastline management. And obviously, your main case study for coastline management was the Holderness Coast. Now, hard engineering is particularly employed along the Holderness Coast. Hard engineering, remember, is a permanent structural change. It changes the natural processes of the environment to try and protect it. It has advantages in that it's long term, it's usually effective, and just requires regular observation and maintenance. But it is very costly. Governments need to plan for schemes like this to ensure coastlines are protected, and they need to treat whole sediment cells as a sediment cell. So the UK government doesn't treat small areas on their own. They treat whole cells at one point in time to protect the entire cell. So here on screen now, you've got essentially a summary of 5 types of hard engineering: groins, sea walls, rip-rap rock armor, revetments, and also offshore rock breakwater. And you've got a description, their purpose, their impact, and their cost. Okay, now you only need to focus on 3 of these, really. You don't need to know all of these in detail. So let's just take the first 3. Okay, so let's take groins. These are vertical stone or timber fences perpendicular to the coast. The purpose is to prevent longshore drift. They stop deposition moving further along the coastline. They prevent longshore drift, but they also starve the coast and the beach of sediment. Now that costs around 150 to 250 pounds per meter. Let's compare that with a seawall. Seawall is usually a concrete reinforced structure with a bullnose profile, so it tries to push the waves back out to sea. It's a physical barrier to stop floods along the coastline. It's designed to dissipate energy, to reduce energy of waves. What it does essentially is it destructs foreshore elements of the environment, such as dunes. It reduces beach volume as well. It reduces the amount of beach there actually is because it stops it from going further inland. Now, seawalls cost £3,000 to £10,000 per meter. So that is quite a lot of money compared to groins. Finally, we got riprap or rock armor there. So these are large, hard-wearing rocks weighing several tons. They're used to dissipate and reduce wave energy. They're used in front of seawalls often to stop them eroding the seawall itself. It reduces wave energy. It allows deposition to take place as the waves slow down when they hit the rocks. And these cost £1,300 to £6,000 depending on the size of the project. So you can see combined that all of these three that we've gone through in terms of groin seawall and riprap rock armor are quite costly, and some areas need all three put together. A lot of the Holderness Coast has all three of these things. Somewhere like Walton on the Naze on the East Coast as well has all three of these things. So it becomes a very costly process to install all of these hard engineering strategies to protect the coast. Now, there are three types of soft engineering strategies you should have looked at: beach nourishment, cliff drainage, and dune stabilization. So beach nourishment is actually seen on the left-hand side image at the top here. And this is essentially where you replace beach sediment, you add more sediment to the beach. We're replacing it because it's been lost by erosion, or because we want to make the beach larger, or because we want to build up around the beach this kind of band of dunes like you see here, artificial dunes. It's about £20 million per kilometre of beach. So yes, it covers a wide range, but it's still very expensive. Costs are very high, and you need to redo it every couple of years. It doesn't last forever. We've then got cliff drainage. So this is adding a slope to the side of a cliff or the side of a beach to increase its stability and the amount of drainage it has. This costs around £1 million per 100 meters. So this is less expensive than beach nourishment, but it can be disruptive during construction. And again, it needs to be redone after a few years. It doesn't last forever because of swash and backwash changes, because of the amount of sediment that's being deposited. And finally, this is often seen as the most progressive and sustainable one. This is dune stabilization. Now you can see an image of this in the right-hand side here, where there are small marram grasses planted there to stabilize the sand. This is essentially where we put fences in place, and we may plant as well to stabilize dunes with lime grasses and marram grasses to try and hold the sand together. That reduces erosion. These cost £400 to £2,000 depending on the area size, and they can be very cost effective. These are the cheapest type of soft engineering strategies generally, and they're also the most environmentally friendly. So there are your three soft engineering strategies along a coastline to manage it. Now, in terms of that, we want to think about sustainable management now. So remember, sustainability is all about managing today what we can, but also not damaging the prospects of future generations. So allowing them to also be able to manage that coastline and have it as an element or asset of their life. So management can lead to conflict, like in the Maldives. So in the Maldives, we've had a construction project of new artificial islands. Now, the Maldives, of course, is very important for tourism and wealth created by tourism. They've been constructed to be safe places for people to go when sea levels threaten lower lying natural islands of the area. There has been potential conflict over it because investment in the capital city of Mal And the construction of some new islands has meant that isolated communities are maybe ignored or forgotten. Some of the communities that are really at risk in the Maldives have actually been left behind, haven't had infrastructure put in place to protect them, and these artificial islands have been given precedence over those poorer people in the existing islands. Sustainable management of more traditional income sources, such as fishing, is overlooked in favour of tourism. Tourism is a bigger wealth creator than fishing, so tourism is prioritised. Conflict has been potentially reduced by mangrove protection and investment by the Japanese government so that damaged mangroves are replanted. So the Japanese government has had a role here in helping to replant mangroves, which are tree, grass, and plant areas by the coastline, which act as environmentally friendly way of obviously sucking in carbon, but also act as a good way of reducing erosion and flooding. Now, these have been planted to try and protect the coast a bit more. So that's one way that the conflict has tried to be resolved. But again, in future, as sea levels rise, the Maldives is likely to be a place where there is more conflict due to the lack of protection for people living on some of the islands in Maldives. Now, we're going to quickly look at the ICZM approach to managing a coastline. So let's recap sediment cells briefly. So sediment cells are increasingly being used alongside ICZMs, which are holistic approaches, and shoreline management plans, or SMPs, to manage coastlines. I said earlier in this GeogPod that increasingly the UK government is looking at all of the cells and managing the cell as one rather than separate parts of a cell. So there are 11 cells in the UK, as you can see on the map on the right hand side. And remember, those cells have inputs from the source, processes, and outputs for the deposition. So these ICZMs then are integrated coastal zone management strategies. And this is basically a holistic approach to managing a coastline. It's an all-encompassing approach, trying to do everything at once. So the idea was developed in 1992, and the idea is basically that a whole coastal zone is managed, not just one place in that coastal zone, to try and be more sustainable and to try and manage it so that people's livelihoods are not impacted. So they're managed as a whole unit, and shoreline management plans, or SMPs, are used within specific areas of each cell. So you may have 5 SMPs in one cell to ensure local agreement, to ensure local consultation, and backing or support of the plans in each cell to adapt to local needs. So there are 4 decisions that are made within shoreline management plans and within coastal management in these cells in general. And they are no intervention, manage retreat, hold the line, or advance the line. Now, this is basically a broad decision taken on each coastline. No intervention is no action taken. We don't invest in that area. We don't try and build things to protect that area. It's not worth it. There's nothing economically valuable there, and we will just let the sea take over. Somewhere like Haysborough in the Holderness Coast is an example of this. The next example is managed retreat. Now, this is where we allow the coastline to recede, or we allow the sea to take over, but we manage it into certain directions. So we allow it in certain parts of the cell. So this is being considered in Holderness in the future. As recession is becoming more and more difficult to manage, the government and local councils in the area of the Holderness are considering allowing the sea to take over in some parts of the Holderness coast and protecting others. We then have the hold the line approach. Now, the hold the line approach is exactly what it says on the tin. Hold the coastline where it is. Build defences so that it stays where it is. Protect what we've already got. Try to stop further erosion from taking place. This also happens in the Holderness Coast at the moment, and it's to try and protect the most socially and economically important areas. And finally, we have advance the line. Now, this one's very hard to do because you have to have minimal levels of erosion generally for it to happen. Advance the line essentially means building new defences out towards the sea to reclaim land. So stopping the sea actively from coming any further and in fact pushing it back outward. A very difficult one to do and a very, very costly one to do. So there are the four types of decisions that are made along a coastline for how it will be managed. There are two other things that are done when we're making policy decisions that are really important to help us decide what to do. So to decide whether to not intervene, manage retreat, hold the line, or advance the line, we complete two things. First one's a cost benefit analysis, and the second one is an environmental impact assessment. So a cost benefit analysis is basically where we weigh up the pros and cons of managing that coastline. What is it that's valuable in this area and needs to be protected? What's not? Is it worth it? So Haysborough on the Holderness coast, long term the plan here is manage realignment, but so far there's not really been any of that. So far it has literally been no intervention. We need around £6 million to manage the Haysborough coastline. This is very, very expensive, but it would protect value of the property behind it. And actually, if we were to pay compensation to the people living in Haysborough, it would cost more than £6 million. So you may think, on a cost benefit analysis, therefore, £6 million to protect those homes and those livelihoods at Haysborough, it would cost more than £6 million to pay them off, to let them lose their homes and land. Maybe we should just pay the £6 million to protect the area. That's the idea with a cost benefit analysis. An environmental impact assessment then, an EIA. This is usually carried out for any type of coastal management. It usually informs the cost benefit analysis. Okay, so it usually is done before the cost benefit analysis. And what it does is it tries to identify the short and long term impacts, positive and negative, of coastal management strategies in that area. So it looks at the environment there, it looks at what managing it might do to the environment in terms of water quality, ecosystems, air quality, sediment flow, water flow, and so on. And it gathers all of that environmental data to then look at the cost benefit analysis of what types of management could be put in place along a coastline. Now, in terms of conflict and winners and losers, you've already got some from the Maldives, for example, but there are two major case studies here on screen. So the Blackwater Estuary in Essex is one you should have looked at, or you might have looked at something similar. And then, as I said before, the Maldives, which you've already started looking at, and I'm just going to go into a bit more detail on. So let's start with the Blackwater Estuary. So this is an example where all stakeholders agreed on the course of action. So all stakeholders in this case were winners. Farmland here is prone to flooding. Traditionally, it was protected by flood embankments, so walls around where the areas are normally flooded. Over the last 30 years, it's become clear that this isn't sustainable and not environmentally friendly. So the radical plans for the Blackwater Estuary in Essex included the Essex Wildlife Trust was purchased Abbott's Hall Farm. That was a protected farmland area, and 4,000 hectares of managed realignment was put into place, creating new salt marshes. Now, the benefits of all that included the farm owner receiving market price for their farm. There was a high hold the line cost avoided. We didn't need to hold the line any longer. Water quality was improved. New paths and walkways were created for leisure and tourism activities. And it basically meant that environmentally, there was a big gain here. There was no more construction of hold the line management strategies. The sea was allowed to take the land over a bit more. It allowed the land and the sea to interact naturally, and that meant that they were able to basically create more tourism and leisure activities out of that area being managed effectively by the sea. That's an example where all stakeholders, so businesses, farmers, the public, the local council, the government, all agreed on the course of action. Now, that's very rare that you get all of the stakeholders to agree. So they were all winners. Now, the Maldives is a bit different. We know that the Maldives has undergone rapid unplanned coastal development because of tourism, urbanization, and also tourist resorts being developed. And defences put in place to protect the islands have been piecemeal. They haven't been very effective at all. The main losers are the poorest people on the islands of the Maldives. So farmers and residents, who are mainly the poorest people, lack a formal land title, so they cannot claim compensation if their land is destroyed by, for example, storm surges or saltwater encroachment or flooding by rising sea levels. So they are massive losers in this case, the farmers and residents. Coastlines there are becoming more vulnerable because of this sea level rise, because of cyclones, because of tsunamis, and sea levels rising in general. Individual property owners in the Maldives have had to take responsibility basically for their own land in the absence of proper planning and coastal defences. So you can actually see here the massive difference between a developed and a developing nation in Essex and the Maldives in terms of how the planning procedure takes place and how, in the Blackwater Estuary example, we have agreement on all sides of the stakeholders on a very well thought out plan, versus the Maldives, a poorer nation, less planning in place and less implementation of planning, more losers as a result. So they are two contrasting case studies you can use to look at conflict or to look at winners and losers due to management of coastal flooding and sea level rise. Now, that is the end of EQ4, which was how coastlines can be managed. So please go back and use EQ1, 2, and 3 as well as a holistic revision approach to the coastal landscapes and change unit. Please do not only rely on all of these 4 videos for your revision for your exams, whether that be IPs or A-level exams in general. It will not be enough, but it is a good summary and reminder of the main things involved in the topic. As ever, any questions, let your teacher know, and hopefully you found this useful. Thank you.